And let's now look at another problem, a different problem on the standard normal distribution, where we're still finding areas, but approach things in a slightly different setting. So again, we are given an n0, 1. That means we are working on the standard normal distribution. And let's draw the picture of the bell curve here. Bell curve with center at 0, sigma 1. Random variable label here is the capital letter Z. And so now let's say I am looking for, and we can call that part A. I want to find the probability that on this bell curve we have a z-score that is either less than or equal negative 1.05 or a z-score that's greater than or equal to 1.25. All right. And so the challenge comes out from this or keyword right here. So let's try to understand what it is. So as far as the picture, so definitely in this problem here, in order to be successful, let's first have the picture drawn down right here. So negative 1.05 is a value, is a z-score somewhere to the left-hand side of the mean in the center. So negative 1.05. And forgive me if I'm off scale or anything like that, but that's not the point, to be exactly on scale. And then positive 1.25 is somewhere to the right-hand side of the mean. And so the way how our event statement here is reading, we want z less than or equals negative 0.05. So that means immediately we can produce for ourselves an area shaded to the left of negative 1.05. And then or we also considering, so or here means we extend our possibilities. So we, aside from that, we also count those z-score. We also look for those z-score greater than or equals 1.25. So that's what the or means. We extend the possibilities, we extend our count, our consideration. So we also want to consider those z-score above or equal 1.25. So that means additionally we have another area being shaded to the right hand side of 1.25. And so now let's have a closer look at the picture here. We actually have what I so-call, in so many years of my teaching experience, I refer to this situation here as we're having disconnected. We are in a situation where we are finding disconnected areas. Okay, so we have two pieces of area, a piece here, a piece there. The same kind of problem. Sometimes it can bring us into the kind of bell curve where we have multiple disconnected areas. It could be a piece here, a little piece here, a little piece there, and a piece here to the right tail. So these are all classified as the disconnected areas kind of problem. And so I am going to show a method that I'm not saying it is the fastest method, but it is the easiest method to understand. So anytime you are solving a problem where we're looking at disconnected areas like this, then the only thing we need to do is just find all pieces, okay? Because it's disconnected areas, so we have a piece here, we have a piece there, we have so many different pieces scattered around throughout the entire bell curve here. So let's find all pieces. And after that, once we've found all little individual pieces, we're going to total up. That's it. Because in the end, anywhere our shading reaches, that's where we have to consider. So, and I said earlier, after we shaded this one, we additionally shaded further to the right hand side of 1.25. And that's why in this philosophy, in this fundamental, we are finding all pieces and add them up. And so now to find the first piece, and really whichever piece that we can start out first, it's pretty much the choice of the person who does the problem. I personally start out with the left piece here. So the left piece here is really the area or the probability where we're looking for z-score less than or equals negative 1.05. And so doing this here is nothing but just calling up the normal CDF command with an indefinite lower end. So here I'm going to have to call that negative 1E99. And the upper end is here for that left piece. And so negative 1.05 here. The mean of the bell curve is 0. The standard deviation is 1. And that's how we can get the answer to this left curve, to this left side piece. So let's now see that on the calculator here. So now I am going to call my normal CDF command, second variables, scroll down to option number 2, hit enter. Now I'm going to enter negative 1E99. And then the upper end this time is negative 1.25. Okay. And actually it's negative 1.05. All right. And so I'm going to hit enter for a few more times. And now the answer to this piece of area here is going to be 0.1468 and a lot longer. It should have been 0.46859 and a lot longer. But that's the area for this piece right here. So the other piece, on the other hand, is done as finding the area. Now, so I'm talking about if we individually finding just that piece, then it is the area on the bell curve where we're looking for z-score greater than or equal 1.25. And so now to find that answer, we are again going to call our normal CDF command from the calculator. And for this interval, for this picture over here, we do have a lower end, a finite low end, a definite low end. So it's 1.25 is the low end. And the upper end here in this case is a positive 1E99. And comma 0 for mean, comma 1 for standard deviation, close the parentheses. And now we are ready for finding some answers again. And so back on my calculator screen, allow me to clear out my calculator screen right here. So second variables. Okay, so my lower end this time is a positive 1.25, and the next one down is positive 1E99. Okay, and ready for the answer. So now with this one here, we're looking at final answer being 0.105649. It could still be a lot longer. But so now we are going to add these two answers, because so far we have found all pieces. So all of the individual pieces. But now the next step now is to total up all of the little pieces together. So we have a piece here, we have a piece there. It is critical. It is critically important to maintain the exact precision. I highly recommend that let's keep all of these because any of these is not the final answer yet. So let's keep any of these in a complete precision. And so the calculator should have a way for us to store one of our answer. So let's say, so on the calculator screen right here, I can also show everybody how to store a current answer to a temporary variable. So there's the store button. Let's hit on store. And so whichever our current answer is, we're going to store that to a variable. So here's the variable x right here. I'm going to click on that. So that this syntax right here on the calculator means this current answer is going to be stored to a temporary variable x. Let's hit enter. So this answer now is memorized by the calculator. And so our next work here is to add 0.105, 649, 839, and a lot longer with the previous answer being 0.14, 6859, and a lot longer. Alright, so now on our computer screen, here's the answer for the previous left-sided left piece of the area right here. And so I am now going to add that answer to the answer that we stored in the x variable. Recall that this area here is being stored to the x variable. And so now on my calculator screen, I am going to add the value that's stored in x. So now I'm going to hit enter. And so the real final answer is here for us, 0.2525089, and a lot longer. And so that means our final answer, and the one that's about to be rounded to 4 decimals, 0.2525089, and a lot longer. And in 4 decimal places, I round it down to 0.2525. And if the problem is asking for percentages, for a percentage as the final answer, then this answer is understood as a 25.25%. And again, on the standard normal distribution, a nice bell curve representing the z variable with center or the mean value at 0 and standard deviation sigma equals 1. Let's look at another problem similar to part A. So here I'm calling that part B. We want to find the probability that on this bell curve we are going to find a z-score that is less than 0.8 or a z-score that is anywhere greater than or equal to 0.15. And so immediately 0.8 is a positive z-score value, but just slightly above or slightly to the right hand side of the center 0 here. So 0.8 is right here on the bell curve on our standard normal distribution bell curve. Positive 2.15 is even further to the right hand side. And at this point, let's agree that we don't need to worry about the precisions, the exact precisions. All it matters here is that really 0.8 makes sense to be to the right hand side of the center 0, and 2.15 makes sense to be to the further right hand side of the center 0. And so now our first inequality in the entire event here is looking for a z-score being less than 0.8. So a z-score less than 0.8 is graphically described as a shading area completely shaded to the left hand side of 0.8. And additionally, this probability problem is looking for a z-score anywhere greater than or equal to 2.15. And so that inequality immediately translates into a shaded area to the right hand side of 2.15. And so once again, now looking at this picture, it is obvious that we are working with disconnected areas. And so as a plan ahead of time, this piece of area shaded to the left hand side of 0.8, we will be getting that done by calling up the normal CDF program from the TI 83 or 84 calculator. And since this interval does not have a definite lower end, then we're gonna run the command as minus 1E99 with a comma. Upper end for this left piece here is going to be 0.8. And with another comma, our center on this bell curve, or mean value on this bell curve, is a 0, standard deviation 1. And so that's how we're filling in the syntax. And on the other hand, this other piece of area, now as a plan, we are going to again use our normal CDF command. And we are running that with low end to be positive 2.15 and high end to be at 1E99. For the similar reason, this interval does not have a definite upper end. And with center 0 and standard deviation 1. So now on our TI 83 or 84 calculator, now I'm going to go ahead and call up the distribution menu, the distribution functions menu. And now after second variables, I am going to scroll down to option number 2, where it says a normal CDF. I'm going to hit enter. So now my plan now is I am going to find the answer to the left hand side piece first. And so in that way, my lower end is going to be a negative 1E99. That's the low end. And the high end is going to be positive 0.8. So 0.8. And again, just like any other problems, we are going to default these two values at 0 for mu and 1 for sigma. That means I am going to hit enter a few more times. And now we are ready for getting an answer. And so this is now going to be, so the answer currently 0.788144466 and a lot longer. And that is the answer to individually the area to the left of 0.8. So the answer now, and this answer is not currently the final answer, so I am going to keep the complete full precision. 0.788144466 and a lot longer. And so now I am going to use my calculator to store this value temporarily. So back on the calculator itself, I am going to hit store and store that value to a temporary X button, which can be found by this variable button right here. I'm going to hit enter. So now our current answer, the area shaded to the left of 0.8 is now stored in that temporary variable X. And let's now proceed to that answer to find the area shaded to the right hand side of 2.15. Or symbolically speaking, it is the probability that we're running into a z-score greater than or equal to 2.15. And so now, and the way of doing that is to simply, again, call up that our normal CDF command with allowing low end to be 2.15 and high end to be the indefinite 1E99 and default at 0 and 1. So now on our calculator again, I am going to call the distribution functions menu by going second variables. Now I'm scrolling down to option number 2. And now the lower end this time is a positive 2.15. So that's what I'm giving to the calculator. I'm going to hit enter. the indefinite upper end is now going to be positive 1 E99. All right, and then we're going to hit, and again we're going to default these two values to 0 for mu and 1 for sigma. I'm going to hit enter a few more times to skip these lines, and now we are ready to execute the command and get our final answer. So now 0.015777 and a lot longer is going to be the answer to this area, or this area shaded to the right hand side of point of 2.15. And so that is 0.015777, 5 and a lot longer. But now we really need to add these two values together. We need to total up, as I said. Each one of these is an individual area, and we have already found. But now the plan now is that once we have found all the individual pieces, we are going to total up, and that's why I'm putting a plus sign here. And I should have done that. I could have done that in a red ink. So now we want to total up. So now to do this with the calculator, keep in mind that we have already stored this value in complete precision to the x variable on our calculator. So now all we do is just to simply retrieve it. So I'm going to go second answers, which retrieves the current answer over here, and I'm going to add to the value that we stored to the x variable, which was this value. So I'm going to simply just type x, and now the total is here. So that means our final answer is going to be 0.803922 and a lot longer. And now since this is our final answer, as usual, I am going to round this, unless being specified otherwise, to 4 decimal places. 0.8039. And that completes our final answer. And in case this problem is looking for an answer expressed in percentage, then we are going to write this as 80.39%.